This is the second part of census mapping, and in this second part we're going to be focusing on map classification and normalizing of data. So in the first video we downloaded our census data and we actually got it into a mappable format. We performed a table join, and we started to work with some of the columns, changing the column type. We need to do that one more time for this particular mapping, and then we can go ahead and start our classification. Right now I have it classed. If I open up the attribute table and take a look at the end here, I have a total population number. So the total population number is being mapped currently. The problem here is that it hasn't been normalized, this number. This is just a number for each one of these containers. It's telling me this is how many people actually are within that particular county. And we have small counties and we have big counties. So we haven't controlled for that area difference. And usually the way that we control for area differences is we actually normalize on square area. And the way that we do square area is we create that geometry in the column, and then we simply take our variable, in this case it's going to be total population, and divide it by the square area. So what we get back then is a population or a person per square mile or square acre, square kilometer, whatever the unit's going to be. In this particular mapping, we're not going to do that process. What we're going to do instead is we're going to normalize on the total population. And I had three variables that I was interested in the first video for the American Community Survey data, and that was male population relative to the total population. And I was also interested in looking at 5-year-olds, so I got those columns and I put them into my final table, and I got rid of everything else. In this particular mapping for normalization, what I'm going to do is I'm just going to take the total population and the male population. So I want to know how many males out of the total population are there on a percentage basis within each one of these tracks. So the way that we do that is we're going to make sure our columns are, the column type are correct, and then we're going to set up the formula in Field Calculator and then go ahead and do the final mapping. And we'll do some classification on the end so that we understand how to do thematic mapping, some of the things that we can utilize in QGIS to make that process a little bit more expedient and precise. So to get started here, the first thing I want to do is I want to make sure that my columns are what I expect them to be in terms of types. So right now I have these strings still, and I have the total population. I did that one already. What I want to do is I also want to do my remaining column for, let's go ahead and open the attribute table here. So my remaining column for is this one, is 100_2. And I've looked that up in the data dictionary already. I know that that column is the male population. So out of the total population, we can see that this number is always going to be a bit smaller. So let's go ahead and do that. So the first thing I want to do is go to Properties, and I'm going to toggle on, or actually I'll go to Field Calculator, and I'm going to make a new column called Male Pop. And this is going to be a integer, and I'm going to go to Fields and Values, and I'm going to go get that one, which is the 2, and I'll drop him in and say OK, and we should get a column here. Yeah, that's fine, that'll work. And we say Apply and say OK. Okay, and then I'm going to go ahead and toggle off now as soon as it draws all the way. It's taking a little time. And I'm going to go ahead and toggle editing, and I'm going to save everything. So I'm going to go ahead and look in my attribute table and make sure it's what I want. So male population, it's the same number there. So now what we want to do is create a normalization between male pop and total pop. And so what we're going to do is we're going to divide male pop by total pop and multiply it by 100. So let's go ahead and do that. So we're going to make a new column. So we go to properties, and we're going to go to our field calculator. And here we're going to go ahead and say, let's just say per for percent, percent male. And we want to have this be a decimal number. And 10's fine. Our precision, we can up it a little bit, maybe 4 or 5. And we want to now, actually let's bring the precision down to 3. We want to now create our expression here. So it's going to be fields and values. So it's going to be male pop divided by total pop times 100. And let's go ahead and say OK. And say apply. OK. And then we'll go ahead and toggle editing, save layer edits. We're going to save those. Okay, and let's go ahead and open up our attribute table and see what we got back. So here we now have a percentage. Looks like it did a pretty good job. Oh, you know what? I cut it off too early. Do you see how some of my records down at the bottom didn't go? So I'm going to run that one more time. So I'm going to go back up to properties and rerun that. So I'm going to go up to field calculator, and I'm going to go into, I'm going to update an existing column at this point. So I'm going to go find my column, which is going to be the last one. So per male, and per male is going to be the same calculation over. So I'm going to say male population divided by total population times 100, and say OK. Apply and say OK. I'm just going to let this run. I think it just stopped it a little bit too early. I'm just going to pause the video for a second while it runs through it. Okay, it did fine on the first run. What I didn't realize is that I didn't have any records for some of these to begin with. So that's why, and it's these island areas that don't have any population count. So I'm not going to worry about those, but it looks like it did everything else okay. So now what we want to do is we want to actually start mapping this percentage number. So I'm going to go over to properties and then go into style. And now I should be able to go to percent male or per male, and I'm going to choose a ramp that I like. So we have many different ones that we can start with. So maybe I'll do this color. And I can also invert this if I want to. So my low values can be, or my high values can be this purple color, my low values can be yellow. Let's make a few more classes. So we'll go up to 5. And under the classification, let's just start with natural breaks. And of course with the legend, that looks pretty clean to me. I like that legend. I put the precision at 3 before, and that's plenty enough for this type of mapping. And then the legend just puts it into 2 digits, which is nice and clean. Remember, you can go ahead and go into the legends to do changes here if you want to. And we could go ahead and say apply. and then say OK and see what we get. So it looks like in terms of the percentage males that there is a relatively low percentage in the South. So it's under 50% in the South, which is interesting. And it looks like the male population in the West is pretty high, and you have some outliers here where you have really even up to 73%. So that's interesting. Let's take a look at some other ways that we can symbolize this. So right now we're doing natural breaks. Let's try standard deviation and see what we get back. And let's go to 3 classes for standard deviation. Or actually, let's make it 4 classes. Oh. And say apply. Okay. Actually, we're doing 3 classes here. And so it looks like, again, to the south, we are lower, and towards the west and upper Midwest, we can see that we're off the standard deviation higher a fair amount. Okay, let's try going to properties and do quantiles, see what we get from quantiles. Say apply. Okay. So quantiles with 3 breaks gives us this pattern. So we can really see the separation of the South from the upper Midwest. That's interesting. And let's go ahead and do equal interval and see what we get from equal interval. Let's up it to 4 classes. Apply. Okay. And here we start to pick out the pocket where we see a real difference in terms of that low class from the other classes, right? So we are putting in, these are these equal intervals, and we can see that there's definitely a low class that breaks right underneath 50%. That goes from 41% to 49%. That's definitively more female than male in the South, which is interesting. And then, of course, we have some real outliers out in the West, and also a few counties here in the mid counties of the country. So depending on the class that you evoke, you're going to get really different results in terms of your mapping, and it's really up to you to pick the classification that's going to make most sense for the story that you're really trying to tell out of the data. And it's really important to understand the basic statistics of the data to then tell the story. And of course, when we're doing basic statistics, we can to get our basic statistics, we can go up to Vector and go to Analysis Tools. And under Analysis Tools, we can just do a basic statistics for a number field. Okay, so in this case, I'm inputting my layer. And I want to look at percent male here. And let's go ahead and run it. So once I run it, I can see that I have missing values of 13. So that's locations that nothing was collected. In the lower 48, I don't think there's any counties that are null. And we can see that we have majority and minority. We also have standard deviation or a coefficient. But what's interesting is that we have a minimum value of 40%. So some of these counties there's just very few men, and then the maximum value of 73%. So we have a pretty big range of 32% across all the counties in terms of the percentage that are male of the total population. So definitely take a look at your basic statistics when you're trying to decide what you want to show in your classification method, because that's going to really help inform where you might place breaks, how many classes you use, what method you actually employ. And again, this week's big purpose is to understand how to do this type of mapping, and importantly, understand each one of these methods and what each one of the methods does well. So make sure that you understand what equal interval versus natural breaks, what they all do of value. There's one that we haven't really touched on yet, I don't think, and that's pretty breaks. So if we go to pretty breaks is just going to give you a nice clean number. And this can be a really nice way to do certain thematic maps. But be careful with pretty breaks, because pretty breaks is just going through the data set and picking up literally pretty breaks. It's making it nice and clean, and it may not be actually the story that you want to tell in the data. So hopefully this video, the second part, sets you up for the normalization that needs to take place between the total population and whatever variable you're interested in mapping. And it also sets you up for spending time under properties and in the actual formation of the theme itself, the classification itself. And one last note, you can also take a look at your histogram. And this is also another way to really help you understand where the data lies in terms of a statistical look at the data itself. So I would not consider this video in any way to be a deep dive into thematic mapping within QGIS for this particular panel that we're looking at right now. This is pretty deep in terms of transparency and blending modes and different classifications, different color ramps that you can develop, which can get very sophisticated, the different methods that we can use. So this world of thematic mapping within QGIS can be expanded out much more than what we've just touched on. But certainly understanding the breaks, understanding how to classify something can get you a long ways in some really powerful census mapping right off the bat.